In this lesson video, we are going to discuss the basics of curve. So what is exactly curve? To make things simple, a curve is a special type of object in Blender that consists of points and lines connecting those points. If you used Adobe Illustrator or Inkscape before, you actually already used curves. In other graphic software, they often called spline or path. But unlike 2D applications, because Blender is a 3D application, each point inside a curve has 3 axis coordinate. Essentially, they can occupy 3D space. You might be wondering by now, so what makes curves different from the ordinary mesh vertices and edges? Well, first, in a curved object, the lines connecting the points don't need to be a straight line. They can bend and twist through the use of mathematical definition. Second, the curved lines have direction, so they are perfect for creating path follow animations or anything that requires a path. In Blender, there are 3 types of curves: poly, Bezier, and NURBS. Let's look at each of these types one by one. The first one is poly. The polycurve type mimics how the mesh vertices and edges behave. So essentially, the lines connecting the points wouldn't be able to bend. They are always straight or linear. The second type is Bezier. Now this is the most common curve type that exists in almost all 2D graphic software. Essentially, the points inside the Bezier curve type have handles. These handles are what actually control the curvature of the line. The third type is NURBS. NURBS is actually an abbreviation of non-uniform relational B-spline. Essentially, in the NURBS type curve, we have 2 sub-objects: the curve itself and the control points. We cannot directly manipulate the curve like how we edit the Bezier curve. What we can do is manipulating the control points. The way these control points positioned will define the shape of the curve. If you press Shift A and then curve and then choose circle here and then press Tab to go to the edit mode, we can tell that this curve object is a Bezier type because the points have handles. Now, if we want to convert this into a polytype curve, for example, we can right-click and then choose Set Spline Type and then choose Poly here. Or you can also go to the curve menu up here, Set Spline Type, and then choose Poly. As you can see, the polytype curve doesn't have any handles, and therefore the lines are just linear like this. If we right-click and convert this back to a Bezier type, we have the handles back, but they are not oriented like the original circle we saw before. If we right-click again, set spline type, and then choose NURBS here, we get this result. These are the control points. And this is the curve. We can tweak the position of the control points to shape the curve. Until now, you might be wondering, why is the curve in Blender has legs like this? Kind of remind us of a centipede. Well, remember I mentioned before that curve has a direction. Well, these are not legs. These are actually arrowheads. They are showing us that the direction of the curve is this way. In Blender, this direction is also known as the normal direction of a curve. So yes, the term normal is used not only on mesh faces, but also on curved lines, although they are actually different things. If you are disturbed by these arrowheads because they look like centipede legs, you can control them by going to the Overlays Options panel. Down here, in a Curve Edit Mode section, in the Normals slider, you can change the size of the curve normals, or just totally hide them by clicking on this checkbox here. Now, if you have a NURBS curve like this, you cannot convert it directly to a Bezier curve. If you try to do that, Blender will just throw an error message. However, you can convert it first to a polytype curve. Then after that, convert it to a Bezier type. One of the most important features in modeling inside Blender is the ability to convert a mesh to a curve and vice versa, a curve to a mesh. This is important because there are specific features only available for the curve object type, and there are specific features only available for the mesh object type. Having the ability to convert between the two opens up a lot of possibilities in 3D modeling. Let's see an example of this process. Let's delete all of these objects, go to the front view, and create a single vertex object. Move this vertex to this location. Let's say we want to create a wavy line. It will be very hard to do this directly using a mesh object, but we can do this easily using a curve object. So, while in the mesh editing mode, hold Ctrl and right-click here, then here, and so on, until we have roughly something like this. Next, go to the object mode. To convert this mesh to a curve, remember, we need to be in the object mode to do this, not in the edit mode. Go to the object menu, then choose Convert to, then choose Curve here. The object is now a curve. We can see the object icon and the data icon are showing the curve symbol. If you convert a mesh to a curve, by default, the result is a polytype curve. So if you need a NURBS curve, for example, you need to go inside the edit mode by pressing Tab, right-click, set spline type, and then choose NURBS here. We can see the previous mesh elements now become the control points, and we now have a curve here at the center. We can drag these control points around to shape the curve, but notice how this curve doesn't really end at the first and the last control points. If you want to make the curve's ends to meet the control points, we can go to the Curve Data panel. In the Active Spline section, you can find an option here called Endpoint U. Turn this option on. Now you can see the curve ends at the control points. Just adjust the curve using the control points as needed. After you are done, you can go back to the object mode. Go to the object menu, Convert to, then choose Mesh here. Now we have a mesh object again. We can go to the edit mode, select all, and then press E, then Y, and then drag it like so. After this, you can continue by adding Solidify modifier and then fix the smoothing group, and so on. But the main idea of this lesson is that you can really make use of the convert operation from a mesh to a curve back and forth to create complex surfaces.